In this lecture, we will discuss logical operators and show how to use them in selection structures. In the last lecture, the conditions that we used in our if-then statements and if-then-else statements were pretty simple. Let's go back to the grade application example. One condition was to check to see if the score was greater than or equal to 90. Another one was to check if the score was greater than or equal to 80, and so forth. These are pretty simple. We're just doing a single comparison. Well, what if we want to handle more complex conditions? For example, maybe we want to check two things at the same time. Maybe we want to check to see if the score is greater than or equal to 60 and that the score is less than 70. We can do this, but the question is, how do we do it? Well, one way is we could include if statements inside of the other if-then statements. So I could do something like if score is greater than or equal to 60, and then in the then portion of it, we can say if the score is less than 70. But if we did this all the time, it would get really messy, and we don't like messy code. So we need to find a better way to handle this. The way we handle this is we use what are called logical operators. These allow us to combine conditions into one larger condition. There are 6 logical operators that we're going to take a look at. Some of them you'll be familiar with in other languages, others you may not be familiar with. We have not, we have and also, we have or else, and we have XOR, or also known as exclusive OR. The not operator works just like in other programming languages. It just negates the truth value of the condition. The way we do this in Visual Basic is we're going to have the word not in front of our condition. So just to give an example, let's say A is a condition that is either true or false. The way we can represent the possible values of a condition using these operators is to use what's called a truth table. So it'll show us all the possible values for our condition. So let's look at the truth table for the not operator. It looks like something like this. The left column gives us the possible values of A. So A is going to be true or false. And then the right column is going to give us the values of not A. So what this is saying here is if A is true, then not A is false. And if A is false, not A is true. So let's do an example using our conditions from before. Well, maybe not the exact conditions from before, but something similar. So let's say here we want to do not 5 less than 6. And one thing I'll mention I haven't really said in previous lectures is notice there's no parentheses around any of the expressions. It's something you're used to in other programming languages, but it's not necessary in Visual Basic. Anyway, so we have not 5 less than 6. So 5 less than 6 is true. So this evaluates to not true, which becomes false. So this whole thing ends up being false. For the AND operator, we would combine two conditions by placing the word AND between those conditions. And the way this works is just like any other programming language that uses an AND operator. Like in Java, for example, you use 2 ampersands. If both of the conditions are true, then the combined expression is also true. Now, if even one of the conditions is false, it could be both, but as long as one of them is false, then the whole condition is false. So let's take a look at the truth table for the AND operator. So here we're going to have 2 conditions. Let's say we have condition A and then condition B, and then let's see the possible values that we would get if we did A and B. So the first row, we have A and B both being true, so that means they're both true, therefore A and B is true. Now let's take a look at when A is true and B is false. Since one of them is false, A and B is false. Then we can look at when A is false and B is true. One of them is false, therefore A and B is false. And then the last one where A and B are both false, well, that means A and B is also going to be false. So let's look at another example here. So let's say we have the conditions 14 greater than or equal to 5, and then the condition 7 less than 10. Well, 14 greater than and equal to 5 is true, and 7 less than 10 is also true. So true and true turns out to be true. Now, the and also operator is one that is not something you've probably seen before in other programming languages. However, you're going to find that it works like the and operator in several programming languages. So I should mention first that it works just like the and operator. You have two conditions. If both of them are true, the whole thing is true, and if at least one of them is false, the whole thing is false. No difference there. The big difference is how they are evaluated. So with the AND operator in Visual Basic, not other programming languages, but in Visual Basic, both conditions are evaluated no matter what. If one is false, the other is true, doesn't matter, they both get evaluated. For the AND also operator, what happens is we'll evaluate the right side if and only if the left side is true. So what happens is it evaluates the left side first. And if that is true, then it'll evaluate the right side of the operator. Now, if the left side is false, there's no need to evaluate the right side. This is similar to short circuit evaluation that has been mentioned in other programming languages, where if you have multiple conditions and you're combining them with and, if the first one's false, or as soon as you find one that's false, there's no need to continue because it's going to be false no matter what. So let's do an example here. Let's say we have 14 less than 5 and also 7 less than 10. Well, we see here clearly this is going to evaluate to false because 14 is not less than 5. That is clearly false. But what happens here is we're going to evaluate the left side first. So it's going to see that this is false, which means the right side, the 7 less than 10, that never gets evaluated. It just gets skipped because we can already conclude that this whole expression, this whole condition is false.